how to use Jason Derulo to explain matter, and kitchen chemistry. All that today on A Moment of Science.
So first of all, we need to talk about what is a state of matter, okay? Matter exists primarily in three states. There is also a plasma, but we have primarily a solid, like ice, a liquid, like water, and a gas, like what's inside of here, the atmosphere of my classroom, right? Okay, now they're very different from one another, although they are all the same in terms of something like that. Let's assume that there is water vapor in my classroom, all right? A little bit humid. So this is water in its solid state, this is water in its liquid state, and this is water in its gaseous state. I'll show you a better example of gases here in a minute, but they can change between one another based on the amount of energy that they have. Okay, the more energy that a particle has, the more that it moves. So inside of a solid, all of the atoms are arranged in such a way that they're very close together. Okay, much like my fists right now. Okay, they do still wiggle, all right? Get your Jason Derulo on. Wiggle, 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 right? So inside of the solid, the particles of H2O are wiggling around. They are in motion. Okay, it is a constant motion, although we can't really see it, because it's not significant enough, all right? In a liquid, the particles are moving around and we can cause them to move, okay? It's something called a fluid, all right? Fluids are liquids and gases. Solids are not fluids, okay? Fluids flow, all right? So liquids can flow, gases can flow, and I'll show you an example of that here in a minute. But the particles in a liquid are a little bit looser from one another. They can slip and slide around. They have more energy, more kinetic energy, because they can move more. Okay, and if you'll notice, ice to be ice, water to be ice, has to be below 32 degrees Fahrenheit, okay, or 0 degrees centigrade Celsius. Water, as soon as you pass that 32 degree mark or that 0 degrees Celsius mark, okay, it turns into liquid, okay? It has more energy, more motion, higher temperatures, okay? Once you get to 212 degrees Fahrenheit or 100 degrees Celsius, water turns into gas. The molecules inside the water are moving so much that they have to space out and they bounce all over the place, okay? So inside this room around me right now, everywhere, there is tons and tons of gas. And all the gas is moving around in crazy motion, okay? And all of those particles move around, they bounce off the walls, they bounce into each other, okay? And that is how gases behave, all right? It also gives them some interesting properties that we'll show you here in just a second. But in terms of their structure, okay, solids are rigid, liquids can flow, gases bounce all over the place. That means that this has a definite volume and a definite shape, okay? It definitely takes up that specific amount of space, and this one definitely takes up it has a definite volume, but it has no definite shape.
So all three states of matter have this really interesting property of compressibility. What does compressibility mean? It means the ability to be squished down. Okay, so for something to be compressible, for instance a solid, I've got a solid here in a balloon, this is a penny. Inside the balloon there is a penny, and I can't really alter the shape of that penny by compressing it, providing pressure, right? Nothing's happening to the penny, it is still penny shaped, all right? It will always be penny shaped. Solids are not compressible. Liquids, okay? Inside of this balloon is nothing but water, okay? How do I know it's water? When I squish it to one side, it changes its shape. Definite volume, no definite shape again, okay? But this liquid is compressible. As I squish it down, it changes the shape of the balloon. Real easy to see there, right? Okay, that is compressibility. Liquids are compressible because they are a fluid. Fluids are compressible, solids are not. Okay, this is a gas inside of this balloon. The stuff that I exhaled, CO2. Okay, CO2 gas is a compressible state of matter. Okay, it can be squished down and changed its shape with the application of pressure. Now I can change between states. I don't have to be stuck in one forever.
So I've decided to kind of step out of the classroom to give you an idea of how phase changes actually occur around you all the time, whether you know it or not. If you're at home cooking dinner, or maybe mom's cooking dinner, and she's making pasta, or you're making rice, something along those lines, you have to boil water to get that going, okay? And when you do that, it looks a little bit like the image that you'll see beside me. But when you boil water, okay, you're taking a liquid and turning it into a gas, all right? And that's called a phase change, when you change from one state to another of matter. And that is called evaporation or boiling. They are literally synonyms, okay? There's also things like melting, and I know you've heard of melting when you think of whenever snow comes on the streets and you have to melt the ice to make sure you can drive. Well, whenever you put butter on your toast, okay, I know my toast is a little bit burnt. I did that so you could definitely see what was going on. Whenever you put that butter on there, what happens is the toast, if it's hot enough, will melt the butter and change the state, okay? And that is literally when you go from a solid to a liquid. That's a phase change known as melting, okay? There is also things like condensation. What I have here is a freezing cold glass. If I put it up above this, okay, and let it sit for a second, the steam collects on the outside of it, and after a while, you'll actually notice that there's water on the bottom of the glass. My hand's wet, okay? And that is because of condensation. That's the opposite of boiling, and that's where you take a gas and turn it straight into a liquid, okay? You can also do that from a liquid to a solid, and we do that whenever we make things like pudding, okay? You take a liquid, it turns into a nice liquid whenever you make it, and it forms into a solid when you cool it down or take energy away. Again, these are called phase changes, where you go from one state of matter to another by either adding or taking away energy.
Now what you'll see and hear before you is something called dry ice, okay? This is dry ice. It's a solid, and as you can tell if you look really closely, you see the gas coming off of it, okay? That is what is called sublimation. A solid goes straight to the gaseous state, skips the middle step, and instantly becomes a gas. Now, I can actually make this sublimation speed up if I do this, okay? And so this is gaseous CO2 that I've got right here, okay? And what's going on as I kick it around here is that gas is coming off and allowing it to kind of scoot across the table the same way that an air hockey table works, okay? Really nifty. So if I take this dry ice and put it into water, I can actually make it to where you can see the gas coming out really, really quickly, all right? And I'll do that for you as we speak, okay? So, that spooky stuff that you see in haunted houses is nothing more than a phase change, okay? The solid going immediately to a gas. If you look really closely inside the beaker, you can see this layer of bubbles that's surrounding the solid, and that's the gas that's coming off of it and immediately going out through the water, okay? Really cool. That's called sublimation. The opposite of sublimation is deposition. And deposition is where you take a gas and go all the way back to the solid, and that's a little bit harder to demonstrate, but it happens a lot all the time around us. So what you'll see right here is something called a phase change diagram. In a phase change diagram, we analyze the amount of temperature and the amount of energy input that it takes, and we kind of compare them to determine the state of matter at certain points on a graph. And we do this all the time. It works for all different types of substances, but this is a good example right here. Okay, this is the diagram for water. Okay, and as you can see, the slanted points are the different states of matter here. We have a solid at the lowest, a liquid in the middle, and a gas at the top, okay, because solids have very low energy, closer to the origin or zero, okay, and exist at very low temperatures, okay, closer to the origin or zero. Now, in the middle, we have our liquids, higher in energy, higher in temperature, pretty simple to understand there. Gas, highest in energy, and highest in temperatures as well, okay? Now, these flat points are where the states change, okay? Right here, as you go from a solid to a liquid, it's called melting, okay? As you go from a liquid to a gas, it's evaporation. As you go from a gas to a liquid, it's condensation. As you go from a liquid to a solid, it's freezing. Now, remember, the lowest in energy and lowest in temperature are always your solids, so that's where it starts. Your states are your slants. States are slants, okay? Flat lines are changes. Flats are changes. States are slants, flats are changes. Real simple to understand there. Make sure you commit that to memory. This will be a tested item.
Whew. Talk about a loaded video. We'll see you in class to talk about phase changes and what exactly a state of matter is. We'll see you next time when we pause for a moment of science.